Okay, this is a video that walks through number 4 in the homework of chapter 2, Chrome Wheels. The problem in the book is at the end of the chapter, and there's orders that are divided into 3 groups of products, 3 different products. There's a standard, an X-Chrome, and an Ultra Chrome. The problem says they receive an average of 20, 4, and 8 orders per day for each one of those. Since Ultra is the company's high-end product, which also has a higher profit margin, the company gives the highest priority to producing those orders. The company produces the other types of orders only when there is no outstanding Ultra Chrome orders. X Chrome has second priority and standard orders have the lowest priority. When an order is finished, it is shipped to the customer on the same day. Production data shows the average time it takes the company to finish production of an order is about 6 days. Data also show that there's an average of 10 Ultra Chrome and 8 X Chrome orders outstanding. Okay, so we're going to put these pieces of information into an Excel. And the questions that we're trying to solve include what is the total average number of outstanding orders in the production system, and also what is the average waiting times for customers who order standard, X Chrome, and Ultra Chrome. So we know that the overall flow time is 6 days. How do we know that? It says right here, production data shows that the average time it takes to finish production of an order, and this is a generic order, after it receives the order, is about 6 days. So this is across all different product. That this is the average overall flow time. Also, we know that there's an average of 10 Ultra Chrome in inventory. So we have an inventory here for Ultra Chrome of 10. We have an inventory of X Chrome of 8. What does that mean? That means within this system, the inventory is 10. That's the average number of Ultra Chrome units, products in the system is 10. And the average number of X Chrome products in the system is 8. So this is the data that it gives us. It also gives us an average of orders per day for each one of these. Orders per day, we are going to calculate or equate that with throughput. So if we have 20 orders a day, then that is our throughput of the standard Chrome. So our throughput for standard Chrome is 20 per day. What's our throughput for X Chrome is 4, and our throughput for Ultra is 8. And in order to add a total, or in order to compute a total throughput for a single day, we're going to simply add the throughput for those 3 individual products. Now we're going to apply Little's law, and we're going to take that throughput, and we're going to take the average overall flow time of 6 days, and we're going to identify what the total inventory is. Little's law is inventory is equal to flow time times throughput. If the overall flow time is 6 days on average, and if the total throughput is 32 orders per day, that gives us an inventory of 192 orders in the system. This is the answer to the first question. What is the total average number of outstanding orders? Is 192 orders, because per day there's 32, and across 6 days that gives us 192 orders in the system. The second part B is what is the average waiting time for customers who order standard wheels. What we need to do is we need to back into the individual inventory for the standard wheels. So this is a pre-calculation before we get the actual answer, which in this case is 8.7 days. Why do we need to back in to the inventory? Because we're trying to figure out, we're trying to use Little's Law again, but in this case, we're not using Little's Law for the entire system and for all orders. We want to use Little's Law to find out what is the flow time. In this case, the wait time for a customer once they, once they make the order until that order is shipped is again going to be Little's Law. But in this case, the inventory and the throughput inputs to this formula need to be in terms of the standard wheels. So we know what the throughput is for standard because they gave that to us up here. We know that the throughput is 20 orders per day. And again, why do we know that? This is the company receives an average of 20 orders. Is that how many goes out? It turns out that in the chapter it talked about an assumption of Little's Law, which is that it's a closed system, right? That all of the inputs actually go out and there's nothing left over. That being an assumption, we can then use the incoming orders that they receive per day as the throughput that they complete per day. So we're going to assume that that is the case here as indicated in the chapter, and we're going to assume that 20 orders per day is the throughput. We need to find what the inventory is for those standard wheels before we can identify what is the wait time or the flow time for the standard wheels. So in order to compute the inventory of the standard wheels, we use this formula. We are taking the total inventory, which we know is 192 from the previous calculation. In fact, let me go ahead and reference that here. And we're going to subtract out the inventories for the X and the Ultra, the Chrome, which they gave us here, the 10 and the 8. So 8 is the inventory in the system for the X Chrome, 10 is the inventory in the system for the Ultra Chrome. That gives us an inventory of standard Chrome of 174. And we take that 174, we divide by the throughput of 20 orders per day, and that gives us a wait time or a flow time, which is the same in this case of 8.7 days. So the average wait time for customers who order standard wheels is going to be 8.7 days. And this should be the longest of all three, right? We know that given the priority system the company has chosen to abide by, standard is the lowest priority. So this should be the longest. We do very similar calculations for the other two products to answer part C. What is the average waiting time for X Chrome and Ultra Chrome customers? We know what the inventories are. We have 10 Ultra Chrome. We know what the throughput is. We have 8 orders per day. 8 orders per day for X Chrome, for Ultra Chrome. This is Ultra Chrome. We take that 10, we divide by the 8, and that gives us 1.25 days is a flow time number. Again, this is using Little's Law. Flow time is equal to inventory divided by throughput. We do a very similar calculation for the X Chrome. Which is 8 orders of X Chrome outstanding. In the system, we have 4 orders per day as a throughput. And we divide 8 divided by 4, and that gives us an average of 2 days. So customers for X Chrome are waiting 2 days. That is correct. X Chrome takes longer than Ultra Chrome. Ultra Chrome is the highest priority. So we would expect to have the Ultra Chrome wait be less than the X Chrome, which it is. 1.25 days is less than 2 days. And that is the recording for problem number 4 in chapter 2.